Hey everyone, welcome back. Ready for another deep dive?
Definitely.
Awesome. Today we're digging into Amazon Aurora.
Oh, yeah.
It's this database system making some serious
Big
waves.
waves in the cloud world. Yep.
For sure, and we've got the research paper right here. Amazon Aurora, Design Considerations for High Throughput Cloud Native Relational Databases.
Straight from the source, those brilliant engineers at Amazon Web Services.
Right. And let me tell you, just skimming this thing,
I know, right?
it can recover from crashes, like full-on crashes,
Uh-huh.
in under 10 seconds.
It's wild.
And this is while it's handling like over 100,000 write operations every second.
It's mind-blowing the performance they've squeezed out of this thing.
So how does it do it? Like, what's the secret sauce?
Well, one of the biggest things Aurora tackles is this bottleneck.
Okay, yeah, bottlenecks, those are never fun.
No, not at all, especially with databases, right?
Right,
So picture this.
right. I'm picturing it.
You've got your data, super important data.
Of course, got to keep it safe.
Exactly. So you replicate it, spread it across a bunch of servers, like for safety.
Redundancy, right. That's what they always say.
Exactly. But here's the thing.
Oh, there's a but coming.
There is. See, instead of being limited by how fast a single disk can read or write,
Okay, makes sense.
you're now limited by the network itself.
Ah, like all those servers trying to talk to each other, that becomes the bottleneck.
Exactly. They're all chatting it up, but the network can't keep up.
So it's like having a multi-lane highway, but then everyone gets stuck at the toll booth.
Perfect analogy.
Yeah.
And get this, some of the traditional solutions, like mirroring MySQL,
Yeah, I've heard of that.
they actually make this worse.
Really? How so?
Every time you write data, it triggers multiple writes across the whole network.
Oh, wow. So even more traffic jamming up the system.
Yeah, it's a recipe for a data traffic jam.
So how does Aurora break free from this gridlock? What's its secret escape route?
Okay, so Aurora has this really clever trick. It pushes what's called redo log processing, right?
Redo logs? Okay, I think some folks might need a little refresher on what those are.
Sure. Think of it like this. Every change you make to the database, like anything at all,
Mm.
gets recorded in this log, like a super detailed to-do list.
All right, I like that. A database to-do list.
Yeah, and then Aurora takes that log and says, here you go, to this separate, super efficient storage service.
So it's like having a personal assistant for your database handling all those little details.
Exactly. It frees up the main database engine to focus on the heavy lifting, processing queries and transactions.
Makes sense, division of labor. So the main database doesn't get bogged down with the logging.
Right, and this separation is like a key part of how Aurora gets such crazy performance.
Okay, I'm starting to see the magic here. But what about data safety? Like, how does Aurora make sure everything is backed up and protected?
Oh, Aurora is like Fort Knox when it comes to durability. It uses a six-way replication strategy.
6 copies. Wow, that's like a backup of your backup.
Exactly, and they're spread across multiple availability zones, too.
Okay, so even if one zone goes down, the data is still safe in another, right?
You got it. But there's more. For every write operation, Aurora needs confirmation from at least 4 of those 6 storage nodes. It's called a 46 write quorum.
So even if an entire availability zone goes offline.
You're still covered.
Wow, that's reassuring.
And here's another cool thing. Aurora splits its storage into smaller 10 GB units. So if one segment has a problem,
You can just swap it out quickly.
exactly, replicate it to another healthy node super fast.
So it's not just about surviving massive failures, it's about handling smaller hiccups gracefully too. It's like always prepared no matter what.
Exactly. Resilience is the name of the game. And remember that network bottleneck we talked about earlier?
So one giving traditional databases a headache, yeah.
Well, Aurora doesn't just address it, it like smashes it to pieces.
Okay, now you've got me really curious. How does it pull that off?
Traditional databases write all kinds of data to storage. Pages, logs, metadata, you name it. It's like a fire hose of information.
And that creates a ton of traffic, right?
You got it. But Aurora streamlines all of that. It only routes the essential redo log records to storage.
Just the redo logs. Huh, that sounds almost too simple.
It is elegant, isn't it? But the impact is huge.
So less data flying around means less traffic jams.
Exactly.
Mhm.
And in tests, Aurora handled 35 times more transactions than mirrored MySQL while using way fewer network resources.
35 times. That's incredible. So it's like Aurora has found this secret back road that bypasses all the traffic.
That's a great way to put it. And that's just the beginning of how Aurora changes the game for databases in the cloud.
Okay, so much to unpack with Aurora. It's really changing things up.
Oh, yeah, for sure.
But we're not done yet, right? There's more to this cloud native story.
Absolutely. Aurora is like this chameleon. It adapts to all these unique demands of cloud applications.
Okay, let's talk about that. What makes it so cloud friendly?
Well, think about how software is delivered these days. So many companies are using this SaaS model.
SaaS, right? Software as a service, where you access software online, no more installing it on your computer.
Exactly. And to make this efficient, these SaaS providers, they often consolidate multiple customers onto a single database.
So instead of each customer having their own separate database, they're all sharing one, like a giant one.
That's the idea.
And that must be a challenge for traditional databases to handle.
It can be, yeah, but Aurora is built for it.
How so? Does it have some kind of crowd control system for all those customers?
You could say that. First off, it supports a massive number of tables in a single database. We're talking hundreds of thousands, sometimes even more.
Whoa, that's a lot of data to juggle. My head's spinning just thinking about it.
It is a lot, but Aurora manages it all, keeps things running smoothly.
Okay, so it handles the sheer volume. But what other cloud-specific challenges does Aurora tackle?
Well, internet traffic, right?
Yeah.
It's unpredictable. You can have these huge spikes in demand.
Like when a website goes viral or everyone rushes to buy the latest gadget.
Exactly. And these traffic surges can bring traditional databases to a screeching halt.
Crash and burn.
Pretty much. But Aurora has this superpower. It's called auto-scaling.
Auto-scaling, does that mean it like grows and shrinks on demand?
It scales up or down seamlessly to match the traffic so performance stays smooth no matter what.
That's pretty impressive. So it can handle crowds and traffic spikes. What else does Aurora have in its bag of tricks?
Let's talk about schema evolution. So in today's software world, things change fast, right? So the database structure often needs to change frequently.
You mean adding new tables, modifying existing ones, that kind of thing?
Exactly, and this could be a real headache for traditional databases.
Lots of downtime, I imagine, for updates.
Yeah, but Aurora takes it in stride.
How so? Does it have a secret schema therapist to help it cope?
Haha, I love that analogy. But seriously, it uses these mechanisms, they're called schema versioning and lazy upgrades, and it makes Aurora super adaptable.
Okay, I'm intrigued. Break it down for me. How do those work?
Okay, so schema versioning, it's like keeping a detailed history of every change made to the structure. So even if data was written using an old schema, Aurora can still read it.
So it's like a time machine for your database schema.
Exactly. And lazy upgrades? Well, it means Aurora only updates the schema of a data page when it's actually modified. It doesn't waste time updating everything all the time.
Smart. It only works when it absolutely needs to. Talk about efficiency.
Right. And there's one more thing, a crucial aspect of cloud applications, and that's availability.
Availability, right? Users expect applications to be online 24/7. No one likes to see a website down message.
Exactly. And this creates a challenge for maintenance, right? Even a short downtime can disrupt everything.
Because the database is like the heart of the application. If it goes offline, even for a few minutes, millions of users could be affected.
Exactly. But Aurora has a solution for that. It's called zero downtime patching.
Zero downtime? How is that even possible?
It's like performing surgery on a patient while they're still awake and talking. Aurora finds these tiny windows when there are no active transactions, and it applies the patch super fast.
Wow, it's like a ninja database sneaking in those updates.
That's a great way to put it, and it's all part of Aurora's design for always-on performance in the cloud.
So we've covered so much about Amazon Aurora.
Yeah, it's a beast.
Totally. But, I'm curious, how does it stack up against other heavy hitters out there? Like, what about Google's Spanner?
Oh, yeah, good point. Spanner is a fascinating system. It's like Aurora's rival in the cloud database arena.
Right. Both built for scale, handling massive amounts of data.
Absolutely. Both aiming for that high availability, keeping things running no matter what.
But I keep hearing about Spanner taking things even further, like to this global scale level. What does that even mean?
So with Spanner, you're talking about handling data that's spread across multiple data centers, even across continents.
So while Aurora is all about resilience within a region, Spanner is aiming for, like, world domination. You could put it that way. And to achieve this, Spanner has some really ingenious tricks up its sleeve.
Like what kind of tricks do you need for global database domination?
Well, one of the most interesting is how it handles timekeeping.
Timekeeping? You mean it has its own internal clock or something?
Not exactly an internal clock, but it uses this network of GPS and atomic clocks to make sure everyone's on the same page, time-wise.
Wow, so it's like hyper-aware of time down to the nanosecond.
Pretty much, it needs this global time synchronization to keep everything running smoothly.
But why is that so important? Why does Spanner need to be so obsessed with time?
Because it's dealing with transactions happening all over the world, potentially at the same time, and it needs to make sure they're executed in the right order.
So no matter where you are, Spanner makes sure everyone's playing by the same rules, no time paradoxes.
Exactly. And this global consistency opens up some amazing possibilities.
Like what can you do with a globally synchronized database? Well, for example, you can take consistent backups across huge distances no matter where the data is stored.
So even if your data is spread across multiple continents, you can still back it up reliably.
Exactly. And you can run queries that span multiple data centers, get a unified view of your data.
It sounds like the ultimate tool for companies operating on a global scale.
It's definitely a powerful option, but it's worth noting that this global consistency comes with some trade-offs.
Trade-offs, like what every superhero has their weakness, right?
Exactly. Remember how we talked about Aurora's asynchronous processing, how it keeps things moving quickly?
Yeah, it's like a well-oiled machine.
Well, Spanner takes a more traditional approach. It uses these two-phase commit and two-phase locking protocols.
So it's a bit more cautious, a bit more coordinated in its approach.
Yeah, you could say that. And while these protocols guarantee strong consistency, they can also add some latency and complexity, especially when you're dealing with a system spread across the globe.
So it's a classic trade-off. Spanner prioritizes consistency and global reach, while Aurora focuses on speed and efficiency within a region.
That's a great way to put it. They each have their strengths and ideal use cases.
So it's not a one-size-fits-all situation. It depends on what you need the database to do.
Exactly. And it just goes to show how diverse and innovative the world of database technology is these days.
It's mind-blowing how much things have changed.
Yeah, it's exciting.
Well, on that note, I think we've done a pretty good job of diving deep into Amazon Aurora, exploring its architecture, its cloud-native features.
And even taking a peek at its rival, Google Spanner.
Exactly. We've seen how these database systems are evolving, meeting the demands of today's applications, and who knows what the future holds.
It's an exciting time to be in the data world, that's for sure.
Absolutely. So to all you listeners out there, keep exploring, keep learning, stay curious about the amazing world of data, and we'll catch you on our next deep dive.